Hey guys, can you hear me? Can you write something in the chat just so we can confirm?
Yep.
Hello, hello.
We can probably say something.
There we go.
So we can the audience write in there too?
Yes.
Okay. Oh, there we go.
Perfect.
Hey, Brian.
All right.
Oh, yeah. Everyone's piling in. Awesome.
Okay, cool. So for this session, it'll be on doubling down, adding additional services with validation. And I'll let the speakers take it away from here.
Thanks, Shinju. So, hey, everyone. My name is Dan Elitzer. I'm with IDEO Collab Ventures. We're an early stage venture fund that's affiliated with the design firm IDEO. And we invest exclusively in early stage crypto, blockchain, distributed web startups. And I'm really excited to be monitoring this panel with two people who are both very knowledgeable about this space and also have really cool networks and services that they've built out that are really complementary to a lot of the other stuff that you've been hearing about so far today. So to get started, I'm going to ask Yaniv, do you want to give a little introduction for both yourself and the Graph protocol?
Yeah. Hi, guys. I'm Yaniv. I'm the project lead at the Graph. So we're an indexing and query protocol for Web3. So we index data from blockchains like Ethereum and storage networks like IPFS and make it available for querying over GraphQL. So we've been live with the hosted service for over a year now. We launched that at the last Graph Day last January. And since then, we've had a bunch of projects like Uniswap and Synthetics, Moloch, ENS, Aragon, and many more build subgraphs, which are these basically projects that allow you to describe how to index some subset of data. And you can have your own GraphQL schema, and it stands up this like GraphQL API for letting you query like your portion of the graph. So we've been working on our decentralized network since the beginning, but we wanted to launch and have something that projects could build on right away. And the last few months, we've been a lot more active sharing details about the decentralized network. So we published a post called The Graph Network in Depth, which goes in a lot of details about all the different roles and participants and how the network's going to work. We also published another post more recently, I think called Modeling Cryptoeconomic System or Protocols as Complex Systems. And that's a really cool detailed look also at how we think about protocol design. And we're excited to be moving into a phase where we're going to be bringing on third-party node operators to help provide this service to the community, and excited to dig into that today.
And Yaniv, before we get any further, can you just give a quick explanation for folks who might not be as familiar? Why is it important to have this data structured, right? Blockchain data is public. So what are you enabling that is not just available out of the box if you're operating an Ethereum node or an IPFS node?
Yeah, so when people try to build applications, they usually need to be able to access the data in like a specific way. Like maybe I'm showing a chart and I want to have the data that can populate the chart, or a table, and I need to be able to sort, filter, paginate that table. So that's common for any kind of application. And usually if you're building like a Web 2 app, you might hit like a REST API or something that is actually hitting a database. And so there's a bunch of servers that's running on the back end that's making that data efficient to query. And that's a layer that's just been missing from blockchains. Basically, with the blockchain, you're just producing these blocks, and certain data is indexed. Like for example, in Ethereum, account balances are indexed, but a lot of the data may not be indexed and not in the way that you want to be able to query it for your application. So that's why you have to have this kind of indexing layer on top.
Awesome, thank you. And Michael, can you introduce yourself in Pocket?
Yeah, hi everyone. My name is Michael O'Rourke, out of Pocket Network. I'm out of Tampa, Florida, so the other Bay Area, and yeah, we've been working on Pocket since about late 2016. A little bit of myself. I got in Bitcoin 2013 when I bought my first Bitcoin on Coinbase, which is really exciting. And since then, around that time, was an iOS developer myself in terms of my background before I went into blockchain full time. Studied actually history in college, so was a self-taught developer and have slowly moved down the stack over the last 6 years or so. And started writing smart contracts in Ethereum with my co-founders in late 2016. Used an incredible service called Infura, and really saw the importance of this service for Ethereum, especially as the ICO boom happened and all these dApps, all these incredible dApps were being built, and Infura was really powering all of this. And part of our core thesis back then was we think there's going to be hundreds or thousands of blockchains governing our lives in the future, and all of them need an Infura type service, right? This kind of API / backend for these applications, right? So we started thinking about what a protocol would look like to be able to solve this problem, and we ended up thinking that the full nodes are the core reason behind Infura, and effectively Pocket is a protocol that incentivizes people to run full nodes for any blockchain. So we've come up with a system to effectively validate API requests, being eventually consistent. So this happens at web scale, which is really exciting. And these API requests get validated. And on the supply side, or the node side in this case, they then earn Pocket, or our native cryptocurrency, for that, for providing that service. We are of the belief that anyone can run a full node. And we think that through open source incentives, and through just open source protocols and those kind of incentive models, we can actually break open kind of these siloed kind of IP in terms of deployment artifacts and things like that, where if you can really bring that into an open source protocol, people are actually more encouraged to knowledge share, and we could potentially reach some kind of collective economies of scale together, which I think is really exciting. So in terms of the project, we were working at late 2016. We actually launched our minimum viable Pocket MVP April 15th of last year. So really, I'm really happy to see other protocols and other projects really focusing on actually iterating. So thank you, Yaniv, for that, and some of the other projects that have presented today. But yeah, we launched April 15th, and it's been really great to see the growth in that. In terms of hard numbers, it's still pretty small, but it's been really exciting to see the growth. In July, we were doing about 7,000 API requests a day. In October, we were doing about 100,000. And in December, we were reaching well over 4 million, which is really exciting. So we've had some projects like a decentralized exchange switched over to Pocket called Saturn Network. And we're in, you can pick Pocket as a provider, for example, in my Ether wallet. And we're in Nifty wallet and a whole host of other kind of smaller projects as well. And yeah, so just to take a step back, actually, so Pocket, in the spirit of this conference, is actually an application-specific blockchain using Tendermint, actually. So we forked the Cosmos SDK into something called POS Mint. And what POS Mint serves is the Pocket architecture, which is a actually pure proof of stake. So there's no delegation in Pocket. So we're really excited about this because we feel like we actually are kind of expanding the design space of building blockchains on Tendermint. So it's something that we're really excited for. So where we are today, we're actually running our testnet internally. We're really excited to have our public testnet February 11th, and we're on track for a launch for our mainnet May the 4th. So really excited for that, and I'll leave it at that.
Awesome. Well, thanks for those intros, guys. So the kind of concept behind this panel is that if you're running a validator service, you've already got, in some cases, pretty resource intensive requirements in terms of running a full node. But the saying, once you're doing that, you are able to monetize it in certain ways natively through the protocol. But also running a graph node or also running a Pocket node allows you to potentially do additional monetization on top of that node and kind of get better return on those resources you're already expending. So can you talk to me a little bit about, for your respective protocols, what are the kind of minimum hardware requirements in terms of running this? How does it compare to the requirements of running nodes for some of the underlying blockchains that you support?
Yeah, I can go. So for the graph, you can think about our protocol as basically being like this indexing database layer. So to run a graph node, you just need a regular kind of Linux box, Medium or large size could be good, but it doesn't need to be much more than that. And then you need a Postgres database. So the actual underlying data store that we use is kind of abstracted from the application developer, but right now the current open source graph node that we have does use Postgres under the hood. So you just need a database like that. And then other than that, you can really run it anywhere. We don't have the same types of like uptime requirements, for example, that you would need for like a proof of stake blockchain. Ours is a different kind of protocol. Would be interested in actually like discussing different types of protocols and like nodes that people could be running, but we call ours like a service protocol as being a category distinct from like a blockchain kind of protocol, where really you're just providing a service to the network, in this case, like indexing and query processing. And I think those types of protocols have kind of different characteristics as far as how you need to administer those nodes.
Does a graph node have to run an Ethereum node together, or can it? Are those two things separated?
Yeah, they're separated. So when you start up a graph node, you just need to point to an Ethereum node, and you could be running one locally, or you could be using like a remote one. So you totally could use the Pocket network or something to be your Ethereum provider if you want. And basically, for a graph node, think of it as like ingesting all of this other data. So it could be ingesting data from Ethereum, from IPFS, or from different networks. You don't need to be running all the networks yourself. And so, it would make perfect sense to just, connect to external nodes for that data. And then you're processing that data inside of the graph node, and then you're serving clients efficiently.
Nice. Yeah. And on our end, it's a brand new blockchain. The state has not gotten very big yet. So it's, I think we just released a blog post actually about those specific specs. I think we've quoted like a T2 micro with Pocket, right? So it's really like the bare minimum kind of specs that you would need to run a Pocket node specifically. But in our case, every Pocket node also has to run a blockchain node for another network, right? So if you're running Ethereum, the requirements are different for potentially running a read-only node for EOS, for example, or for Cosmos, or for Tezos, right? So the requirements for each one of those chains in Pocket's case is different. And it really depends on what chains you want to run, and how you kind of want to mix and match. If you're, for example, purchasing a server in Pocket's case, how can you virtualize different nodes and everything like that. So it's really dependent in Pocket's case in the blockchains you're running and the throughput that node is running, that node is serving, right? So in Pocket's case, work is actually load balanced across the protocol. So developers don't actually choose which nodes they want to use. And as a result, you kind of have like an average across the network. So in Pocket's case, you'll kind of know ahead of time, like, how much buffer I need to have, how much, what the average node is actually serving in our case, right? So these kind of, this kind of data will be known ahead of time before you run a Pocket node.
And so just to be clear, for node operators on your networks, what's the kind of service requirements in terms of you're kind of in some ways competing with the other nodes on the network to provide responses to queries, right, from application developers. So what are the things that you need to make sure that you are prepared to do well in order to kind of maximize your returns on running a node in the network? Michael, could you kind of go on that first?
Yeah, absolutely. So you absolutely, generally speaking, it's very much similar to what some of the other speakers have been speaking about today, where you want to have, bandwidth that's highly available. Generally, you want to have a solid enough server. So some of these servers can cost anywhere between, $1,000 to $5,000, and be able to fall back. In our case, so Pocket doesn't, at least at launch, we won't be slashing based on your service quality. But the way we do incentivize a better service is if you are falling behind on API requests, right? You are then realizing, hey, I need to get a better server, right? Or figure something out to improve my service. So in our case, kind of the baseline incentives of the protocol, at least at the beginning, will be encouraging you to have the best hardware that you can have, that you can provide, in the best service in terms of bandwidth and everything like that as well.
Cool. And Yaniv, how about for the graph? I assume somewhat similar dynamics are at play.
I think it's actually a bit different. So we, for slashing, it's just sufficient to just be honest, as long as you don't kind of purposely misbehave and send incorrect query responses. You're not actually slashed for things like uptime and service quality. Now, we do have a node monitoring service that we're going to be kind of launching with the network that's basically checking to make sure that people are doing useful work. So we've got like a proof of indexing construction that if you don't submit the proof, meaning you've been doing the indexing, then you'll be put onto a blacklist, which just makes it so that you can't earn inflation rewards, but you're not actually slashed. And so that's just a way to make sure everybody's like doing the useful work that they're registering for. But the graph is a little bit different in that there's no centralized kind of coordination mechanism. The clients decide which indexers they want to connect to. So we have a service discovery layer in the protocol. And based on that, you can discover indexers that are indexing the data that you're interested in. And then you can choose which indexers you want to connect to as a function of price, performance, and security. So the security is how much stake you've got on the node. Performance can just be observed empirically. And for price, the indexers can set their own prices. So we're going to be launching an indexer agent that indexers can use to just automate kind of the price setting and that those types of decisions. So if you want to just kind of set it and forget it and not do anything, it'll work right out of the box. But there's also going to be some strategies that people can go in and customize that can help them provide a better service, either make more money or compete on a price dimension. And so that'll make it so that there is at least an avenue for folks to kind of innovate.
Cool. And so I do want to make sure that we're catching also some questions that are kind of coming in from audience members. And there was some questions about like, what is the kind of limits on the data that your services can handle? Are there like theoretical limits where you're kind of running into some constraints here? Or what do you think about as being the ceiling on what your protocols are capable of doing, especially vis-a-vis like centralized services, right? Because there are centralized alternatives, or in Michael's case, there certainly is centralized alternatives like Infura for you, but even I don't know. There's probably, I'm sure, folks who are providing some kind of indexing services in a centralized manner as well. So, how do you compare? Where do you start hitting limits? Is this really just about being compatible with the ethos of the space and providing something that is truly decentralized and censorship resistant? Or do you actually get potentially performance improvements or reliability improvements as a result?
Yeah, there's no limits in the graph. And we're actually quite confident that a decentralized network can provide these types of services way better than a centralized service. We've been running the hosted service right now for over a year. And, it's pretty challenging for just a single service to really stay up and running and be providing reliable support like 100% of the time. And I would love there to be dozens of other teams all doing the same thing, or if one service goes down, other servers are still up and running. So I think there's a lot of benefit in the redundancy, having like completely disconnected groups of people providing the service. The graph, you could think of it as being kind of sharded in a sense, because each indexer chooses which subgraphs they want to index. So, you might have, 10x replication for any single subgraph. But you can also have a lot of different disjoint sets. You could have some indexers that are only indexing like one massive subgraph. You could have an indexer that chooses to index 100 or hundreds. So really, there's a whole range of variety there, and we expect that just in terms of pure amount of data that's being indexed and queries that are being served, that it's actually going to be a much more scalable and cost-effective solution than any kind of centralized service.
Yeah, I think the Graph and Pocket both have this, and I think this is an infrastructure thing where we have the same kind of properties as marketplaces, where in a marketplace like Uber, right, a driver can only take up to 5 people in a car, right, or 7, right, depending how big the car is, right. In our case, and I believe in the Graphs as well, providers can scale as well as their infrastructure provide, or as well as they design their setups, right. So what's interesting about that is you can have less or more providers and allow the market kind of figure that out itself, which I think is quite interesting. Yeah, and like the Graph, we don't also limit how much a provider can serve, right? If they can max out with all the requests that they're getting, then great, right? If they're getting overloaded, well, then they're missing out on Pocket by not providing as well of a service as they could have. We do limit how much developers can access the network. You do have to pay for it. It's not free, right? So in Pocket's case, developers do have to stake Pocket to actually access the network. We realize that it's an open market for the token. It's not a stable coin or anything like that. So what's great about Pocket is that when you stake it within the protocol, your throughput is locked in. So you know how many API requests you're getting effectively. And that's locked in perpetuity. And in terms of, Pocket being a decentralized network, just like the Graph, and providing better, more efficient service, I think that's where protocols like ours are really, really going to shine, because we are going to be able to find efficiencies that centralized entities wouldn't be able to, right? Whereas, in Pocket, for example, we think that the market will take people to running infrastructure out of data centers and out of their homes, which is quite interesting, because people don't want to have to pay rent on what people are on AWS and cloud and GCP. This has been a constant theme today in terms of redundancy. And what's interesting in terms of cost as well, if you're one entity providing infrastructure, you have to provision a lot of extra infrastructure to account for spikes. The nature of the way websites and everything like that are accessed is, it could just spike up, at any point in time. And a lot of these providers have to actually provision a lot of these extra servers, and that's a pretty hefty cost. And what's interesting about decentralized networks like ours is that we can effectively spread that out amongst many people, and really reduce the need for having to waste that extra infrastructure to provision and just in case, which is we think we can provide up to 10x kind of costs.
Mm-hmm. And so one thing you actually both, or Michael, I think you touched on a little bit more there, was around the incentives here. And in the case of Pocket, you've got your own separate blockchain and network here with its own token. It sounds like you need to stake your native token from the Pocket network as a person who is, or as an application that is making calls to the Pocket network and requesting data. So you need to buy some of that token and then expose yourself to, I know it's not live and trading yet, but you're getting exposed to the volatility of that. You may want to withdraw it later. But what you're saying is, at the very least, anyone who's buying the tokens knows, even if the value of the token goes down, the value of the token goes up, they're still getting a fixed number of API requests.
Correct. Yeah, that's exactly right. So we actually base it on, we actually use, and actually a bit inspired from LivePeer, we actually use participation rate in the protocol to determine how many API requests a developer can purchase at any given point in time. So effectively, when I stake, right, and the protocol dictates that my API potential requests for that same amount of Pocket that I've already staked, if it's gone down, well, I'm receiving better than market rates at this point in time. So if I'm getting a good service and I think it's this is what I need, well then great, I can just keep that staked, right? In the other case where the relays that my Pocket may purchase goes up, I then have to make a decision to say, hey, maybe I want to buy some more relays, so I will unstake and then restake into the protocol. But we try to we have avoided kind of that kind of volatility factor, because once you stake, it's locked in, and that's not changing, which is kind of the important piece there. And also in Pocket's case, you also have an asset that it's not sunk cost, right? You're not paying consistent fees. You're actually paying through dilution in Pocket, right? So we don't have a dynamic block reward. I'm sorry, we don't have a arbitrary static block reward. In Pocket, our block rewards are completely based on the usage of the network. So I get diluted as I use the network, and that allows me to kind of pay in that regard. So you have some interesting dynamics there in terms of incentives and how developers may value infrastructure in the future.
And so then effectively, if I'm running, nodes or validators on Pocket, and I'm receiving my rewards in the Pocket token via inflation, I presumably have some expenses related to operating these services. So then I'm probably selling some of at least part of the rewards that I'm receiving in order to cover that cost. And that's how new tokens essentially enter circulation and go on the market. And then new application developers, whoever can buy those tokens and be able to stake them to make the requests on the network.
Yeah, that's exactly right. And inflation is not the sole answer, because it's not necessarily sustainable over the long run. So because we don't pay through direct fees, we kind of couch the protocol in a couple of phases. So in the growth phase, where you have growth in staking and people are using the protocol, you basically have those new users effectively subsidizing the early ones, and the early users in this case, in terms of incentives, are getting a very strong benefit for becoming a part of the network early on, right? But eventually, that growth will stop, and you cannot perpetually inflate this protocol while not having new income coming in. So actually, that's when we will be implementing a burn mechanism for developers. So that way, the developers who are actually purchasing the service have to continually purchase Pocket and effectively almost like top up their stake over time. But what we think is interesting about this is where you might be paying $100 a month for some service. We think with Pocket you'll actually be paying $10 a month. So it kind of evens out in the end in that regard.
Cool. And Michael, by the way, we can no longer see you on camera, so I don't know if you hit a button or if it's just bad connection or something. But we've kind of got your. There we go. Well, for a second there. Okay. Yaniv, talk to me about the graph. How does the graph work? I think it works a little bit differently from Pocket in terms of the incentives and how developers will pay for this service.
Yeah, the incentives are a bit different. Before I jump into that, though, maybe now would be a good time for me to make a little pre-announcement. So we haven't announced this yet, but I guess now would be as good a time as any to mention that we are going to be running an incentivized testnet starting soon. There's going to be, before that, we're going to do a private testnet.
Do you have a memeable name for your testnet?
We do, but we're not sharing it yet. We're going to wait until the announcement. But for the folks that are on the call, since y'all made this this panel, you can shoot us an email at info@thegraph.com if you're interested, and we'll be sure to reach out so you can participate. But yeah, so to answer your question about the incentives, so indexers in the graph earn both inflation rewards and fees. So end users in the graph pay for queries. And when we initially launch the network, we're going to have a gateway that allows dApp developers to subsidize those query fees on behalf of their users. So if you don't want your users to have to pay for anything because that's weird and we want things to be more like Web 2, then you can just add a credit card or deposit some ETH and pay those fees on behalf of your users. But here it's just a metered billing. So the way it works is there's open competition between the indexers. And so the consumer is always getting the lowest price in that open market, and you're really just getting paid per query for what you use. And then on top of the fees, which the indexers get, they also get inflation rewards. And the inflation rewards that they get is proportional to the signal on the subgraphs. So if you have a subgraph like Uniswap that a lot of people know to be popular, and they can also look at the past performance of that subgraph, then that subgraph is likely going to have more signal on it. And signal is basically stake that these curators do to try to essentially make the resource allocation on the network more efficient. And so the more signal there is on a subgraph, the more inflation rewards the total set of indexers get for indexing that subgraph. So that helps us much more efficiently distribute the resources on the network.
So actually that makes me want to ask another question, is for that role of kind of being signalers on the network, is that then another service that if you're offering like a staking service you might offer, is like, you've got graph tokens, you want to use them to signal, and so if I'm running a validator service, like a hosted service here, I could say, hey, I'll stake your graph tokens for you, and we're going to figure out where you should be signaling to get the best return on those.
Yeah, totally. That would be a great service. And we were just having a conversation internally where some of the dynamics can get really interesting here. With just a few incentives, you can start to get really interesting behaviors. So like here, we have 2 routes that we're working on for payments, but we have in our blog post we discussed our payment channel implementation, and there's a hub that has a payment channel set up with the indexers where you're getting paid with micropayments on every query, and you don't have to settle that channel. You only have to settle it once an epoch, which could be some length of time. And so during that time, you as an indexer actually have some privileged information as to how many queries you're getting for that subgraph during that epoch, and you can actually even use that to signal yourself, and maybe you have some asymmetric advantage there. But you get all kinds of interesting behaviors, but all of it should just end up with the network being more efficient. And definitely there's a lot of opportunities there for indexers either to just kind of compete and have an edge in the network as far as the decisions they're making of signaling, staking, choosing which subgraphs to index, setting prices, and you can also be providing those services to folks that either have tokens that they either want to delegate to you as an indexer or signal on a subgraph, there's lots of permutations there.
Hey, Yaniv, could you talk about the role of curators in the graph? Because I find that really fascinating in terms of these roles that people can play in these kinds of networks, and I'm starting to see like these different roles are starting to grow in terms of different kinds of networks and stuff like that. And I'd just like to hear more about that, just generally on your end of like what their role is and kind of how you see them growing into the graph down the road.
Yeah, so anyone can create a subgraph, and so there's no guarantee that a subgraph is actually providing correct data in and of itself. Now, what we expect to happen is that over time, subgraphs will kind of establish themselves, and when they're important enough that there's a lot of applications that are dependent on them, then people will start paying attention to any updates that they're making to make sure that they're always providing good, trustworthy, correct data. So one job that a curator can do is to actually like dive in, take a look at the code, make sure that everything like looks right. And if an API, then you've kind of vetted it and you're like, hey, this is a good, correct API, then that could be a good reason to signal on it. Another path might be almost like someone who's acting a little more like a VC or something, to be looking at what projects are super promising. If there's a brand new project that about that just built a subgraph and they haven't blown up yet, you think they're going to be the next Uniswap, that might be a reason to signal on that subgraph, because as a curator, you purchase these curation shares on a bonding curve. So the earlier you purchase those shares, the better you do. So that's an interesting dynamic there. And then the curators also get a portion of the fees. And so that's a way that there's an economic incentive to basically predict the query volume in the network for any given subgraph.
Wow. So that sounds like that could get pretty fun. We could have like investing DAOs that are just going in and kind of staking, curating subgraphs.
Yeah, exactly. It's kind of like prediction markets for query volume, which is a nice proxy for utility of an API. And it'll be really nice data for the industry to have too, to know like, hey, these, out of these dexes, this one's, getting the most activity, and hey, let's actually invest then in building more services, in that area. Both in terms of actually kind of creating this forcing function to get people to do active development in areas that have a lot of economic activity, as well as just making sure that then those areas are, have the proper resources behind, serving those APIs.
So there's a question about like doing X times Y equals K for the queries. Sounds like constant product formula. Is that relevant here?
Yeah, I'm not sure exactly what
I think it's probably referring to the bonding curve.
Is for the bonding curve?
I think he's trying to understand like how steep the curve is.
Yeah, we actually, so that parameterization is something that we're still working on. So we haven't decided on an exact curve yet.
Yeah, okay.
I think you made an interesting point about the graph providing interesting data for the industry, because now we're bringing a lot of this developer traffic to these open protocols, which all of a sudden you can derive some interesting things from that kind of activity, whereas a lot of this was previously siloed before. So I wonder what kind of benefits that might provide down the road as well.
Yeah, it's interesting. I think are there, for either of these protocols, are there privacy considerations here that are created that are kind of separate from just like general usage, right? Like, you do a transaction on Ethereum, it's public, you got to be very, very careful if you want to not, dox yourself eventually. But are there privacy concerns with this as opposed to using a centralized service? Like, what are the ways people using these protocols could potentially kind of trip themselves up on the privacy front, if any?
Yeah, that's a great question. In Pocket's case, we don't. There's no metadata that's being saved in terms of the applications that are accessing these blockchains. Really, the only thing that's really saved is a minted pocket, right? So that's a reflection of kind of the usage in aggregate of the service, right? So really, and frankly, you actually have a little bit more privacy in the sense where instead of having one provider have basically full access to your entire history, that gets broken up like amongst thousands. We're thinking Pocket can handle hundreds of thousands or even millions of nodes down the road. So it becomes more difficult to actually kind of reverse engineer that kind of activity as well.
Yeah. So, I mean, you have the same kind of things with like IPFS, right? Where if you have nodes on the network that are serving, then those nodes are going to kind of know somebody wants this file, right? Because I gave somebody this file. I do think it'll be important for people to use like VPNs and stuff, just like when browsing. I think that like part of what we're doing with Web3 is trying to re-architect the internet protocols so that they have the properties that we want. One of which is privacy. And so I think that added awareness, browsers like Brave now have like VPNs built in. And I think that's going to be really important for kind of obscuring, who's asking for what. But then in general, I think that what we're going to have is the split between, and now with Web3, you'll have a lot of choice in how the services run, right? If you want to run nodes yourself, you can run nodes yourself. If you want to use, the public network, you can use the public network, and you can kind of, choose for different things, how you want to run that software. But, for most people, I think that, using just public services is going to be a much better experience. And whatever data then becomes available is kind of public data. And so it's no longer something where it's like one company gets to, Amazon knows in aggregate exactly what everybody's, got in their shopping carts and stuff. And, I think it's better that there's, either data is private and only you know it, or it's public and everybody can see the aggregate economic data. And I think that's kind of a better deal.
Yeah, that's pretty cool. So when we start to think about what it's going to look like when your networks are operating at scale, is this something where you're saying like you're expecting the main validators on your network to follow something of a power law, where there's going to probably be a few large providers who are handling the bulk of the queries, or do you expect this to be people running on their home machines, just doing this kind of as hobbyists and making it very, very flat just distribution?
Yeah, on our end, because the protocol load balances naturally, we do expect the bulk of the providers to be kind of professional outfits, right? People who really can run infrastructure at scale. We think that the economics are such that it'll end up moving. It'll be more profitable to run out of data center as opposed to, on AWS or Google Cloud over time. But what's interesting about Pocket is that it's a low marginal cost to actually run a node outside of your initial startup costs. So you're really just paying bandwidth and electricity. And assuming the requests flatten out, as you said, over time, everyone's going to have a pretty good idea of what the really, the specs of the servers they need to have and what they can really handle. And we actually do expect people to be running Pocket nodes out of their homes and servers, very similar to how, we've got Wi-Fi routers. We see a future where people are running full nodes, running Handshake, Althea, Pocket, all these kinds of services where they're actually, earning income and really spinning these networks down the road. So we really, you've got these amazing projects like DAP Node, Oak Node that are really providing these really simple kind of one-click kind of home kind of setups in some cases. And I think we will start to see, as these economic models mature as well for these protocols, because really they're very much unproven. As we start to see successes, I think we'll start to really see meaningful change in that regard as well.
Yeah, I don't think people are going to be running, graph nodes on their laptops for the same reason you're not running, databases for other services on your laptop today. But we very much want it to be very decentralized. We're purposely putting things into the protocol design to try to stave off centralization. There's always this kind of battle sometimes between economies of scale, which lead to centralization, versus forces that can help keep things decentralized. But one of the reasons we think the decentralized services can be more competitive is that clients, one of the ways that they choose to connect to an indexer is based on performance. And so there's actually a strong geographic component where if I've got an indexer in my building, it can serve me way faster than one that's, on the other side of the country. So, I think that in an ideal world at scale, being an indexer and running nodes for Web3 could be a similar but like more skilled version of being like an Uber driver, like a white collar, more, version of that, where anyone can do it. You can earn real money by doing it, find good places in your local community to set up nodes. It's beefy hardware that's providing great service, and I think we could end up with much faster internet services than we have today.
Very cool. Now, I want to make sure that I give you guys. I think we're gonna be wrapping up in the next few minutes here, but I want to make sure that before we do that, I give you guys a chance to shill and like let people know if they want to dig in and start Yaniv Graph's already up and running in mainnet. Michael, you mentioned Pocket. We're hitting testnet. I think you said February 11th, and hopefully mainnet May the 4th. So, how do people get in touch with you? What are the next steps they should take if they're interested in learning more and potentially adding validator services for your networks?
Yeah, follow Twitter. We've got a newsletter.
What's the Twitter handle they should follow?
At POKT Network. So
POKT Network. Okay.
Yeah. Keep track of our website. As like Yaniv, actually, we also are having an incentivized testnet, likely announcing that in the next 2-3 weeks or so. Would love to have as many people running Pocket nodes as possible. We really think that we can really, I found it really interesting from the consensus presentation a couple hours ago in terms of the node counts of Ethereum. We really hope that we can really make a meaningful dent in those numbers and really improve them for a lot of these services. So super excited. Please check out our website. We're actually releasing a ton of content. We're releasing a full outlay of our economic model in about a week, and we'll start to have some more information on all these things in the next couple of weeks as well. So really excited for that.
Also, shout out to Gabe H. and there's somebody earlier, Sathya. People who are typing up in the chat some of these, like the email addresses and Twitter handles and stuff. It's very helpful. Thank you guys for being on that. Mm-hmm. And Yaniv.
Yeah, so we're at Graph Protocol on Twitter. We have a really active blog with some cool designs where we dive into the network. So be sure to check that out. It's at thegraph.com.
I gotta say, as like the IDEO guy on the call, like the designs on all the graph stuff is like amazing. They've got some of the best developer documentation in the space, and then some of the most beautiful presentations and explanations you'll find as well.
Thanks. Yeah, and I've been working with Carl, our designer, for years, and it's more than just a visual polish, right? You're kind of creating a universe together, both in terms of explaining highly technical concepts and also making it something where people feel something when they're being part of your universe. So you can find all that at thegraph.com. For our incentivized testnet and our private testnet, be sure to email us at info@thegraph.com and we'll be in touch. We think it'll be a lot of fun. Also for developers, we hold hackathons, online hackathons pretty regularly. So you can also find that on our website. If you join our mailing list, you can find out about the next ones. Even as an indexer, it could be fun to know how to build a subgraph. What are these subgraphs all about? Why are so many people using them for their applications? But we're going to be gearing up a lot this year. So moving from our hosted service where we're the only ones running all these nodes to a period where we let go the keys and we let it run wild. So really looking forward to having more people participate.
And one last thing, because we've got a little more time, it sounds like, because we're running ahead, the whole conference is running ahead. If you guys could like have any partnership integration, like anybody coming and starting to use your network, who would it be? Like for you need like what are some of like the most desired, I guess, both subgraphs and then potentially apps that would be, well, I guess it's kind of one of the same subgraphs and who's building on top of it, and then Michael, who do you want using it too?
I'm actually going to answer the question a little bit differently, which is I think that we haven't even started Web3 yet. I think that there's really exciting development going on, and we're solving a lot of the important problems. But I don't even think we've like begun. And so what I'm really looking forward to is all of the new things that Web3 brings on. We're creating a brand new market, and I think it's going to be even weirder than people can even conceive. Bringing on developers all over the world so that they can collaborate on, this shared global internet service, right? Like Web3, all these things that are interoperable, that anyone can contribute to, and you can make money, contributing. What's that going to turn your work routine into as a developer? Having like, the distributed global DevOps team, right? That's basically what you guys are. I think it's going to be really wild. So I'm looking forward to designing all of these, new ways of working together.
Yeah, talking about weird. I mean, taking it to the title of the talk, right? Offering additional services with validation. A lot of the conversations earlier today were about these validators, right? Race to the bottom, these sorts of things. So, and they're all kind of competing for the same market, right? It made me wonder, what if these validators who are in the perfect nexus of understanding economics, infrastructure, and security, potentially providing services that are like, competing with potentially like AT&T or my local ISPs, where, this is a very US case, but I might be able to get, a mobile network virtual MVNO to purchase data in bulk from these big providers, right? What if one of these staking as service providers, offered really cheap service, cell service, where parts of those payments that cell service went to like a local pull together contract, and all of a sudden you're earning like a lottery for paying your cell phone bill, right? And how can you, potentially as like finding different markets, right? Because I think that's a big struggle right now with a lot of these services is we're all kind of like, or at least in the staking of the service and part, kind of everyone's competing for the same market, right? And I wonder what kind of different packages and what kind of interesting things that people can really kind of put together to really kind of offer some things that like my local ISP would never be able to offer, right? Or the local T-Mobile, Boost, Cricket, kind of a thing, right? I just wonder how creative and weird people can really get, where it's like you're packaging Althea with Handshake with this, you become like a bank. I just feel like there's really interesting things that people haven't experimented with yet that really could, one, really open the market, right? You're introducing crypto to people who aren't necessarily using it, right? And find interesting ways to provide these unique services, right? Because we're all building on public infrastructure, and that's a really key difference here. Is Spectrum, my local ISP, owns the wires, right? AT&T, Verizon, they own the waves, right? So I just wonder what kind of different creative things that these staking and service providers can also offer with their expertise, understanding. My users are, I can offer like a Google Maps with Foam or something. Who knows, right? If the economics works out, right, and I earn crypto on the back end through my users paying my cell phone bill, right? Just really interesting things, I think, that'll be happening down the road.
Awesome. So you guys set me up really well too to say, like, if you're building any of those like really cool crazy new things, like come talk to us at IDEO Collab Ventures. We want to like help support you and work with you to build that crazy new stuff that's gonna blow people's minds and open up Web3 and open up crypto and blockchains to whole new parts of the world. So Michael, Yaniv, thank you so much for joining me on this panel. Thanks to Shinju and all the organizers for putting this together and making this happen. And it sounds like we're, I think, about to bounce over to the next talk now, where you also catch my colleague, Gavin, I believe, is moderating that panel.
Cool.
Thanks, you for moderating. Thank you, Shinju, for this awesome conference. And it's been a pleasure speaking with you guys.
Yeah, it was a fun talk. Bye.
Thanks, everyone, for tuning in. People moved over now?
You're muted, Shinju.
Shinji, yeah, Shinji, you're still muted. We
You're
can't hear
muted.
you.